the year it rained for 2 million years. That is how this story gets told, and for once the headline is not far off. Late in the Triassic, when all land still locked into the supercontinent Pangaea, the air shifted. An arid world that breathed dust and salt gave way to relentless water. Storm belts bloomed. Rivers raged red with silt. Lake basins woke up from centuries of sleep. For an interval geologists call the Carnian Pluvial Event, roughly 234 to 232 million years ago, the sky refused to close. The trigger did not fall from space. It rose from below, along a swath of what is now Alaska and Western Canada. A volcanic province called Wrangellia split and spilled sheets of basalt. Those eruptions pumped carbon dioxide and sulfur into the atmosphere, jostling the carbon cycle, warming the planet, and supercharging the hydrologic engine. In rock after rock, you can see the fingerprints, sudden swings in carbon isotopes, spikes of mercury dusted into ancient sediments, whole layers switching from chemical carbonates to silt and sand. At first, the water brought life back to parched interiors. Plants that had been clinging to wadis spread. Freshwater channels braided across flats. Coal swamps restarted in places that had been quiet since the end Permian catastrophe, ending a long coal gap. The world exhaled a deeper green. But every gift hit a cost. Soil slid into the sea faster than reefs and microbes could bind it. Rivers delivered acid and nutrients that set off chain reactions offshore. The chemistry of the ocean lurched. That is the strange rhythm here. Relief, then recoil. The rains helped, then they hurt. The first months of a monsoon can feel like rescue, but years on end turn rescue into siege. In the coastal Tethys, carbonate platforms that had stood like white cities dissolved into low ramps. Oxygen thinned in deeper pockets as warm water held less of it, and fresh sediment smothered what lived there. On land, low places became inland seas. Up high, lightning stitched every horizon. Listen to the beat of this world. Sunsteam deluge, pause. Then again, harder. Many teams now think the Carnian was not a single storm, but several pulses spread across a million years, each eruption volley tugging climate and seas. After each pulse, ecosystems tried to stand. After each, many failed. You can watch that pulse train in the strata like a heartbeat. What does 2 million years of rain sound like when you are a reptile clinging to a mud bank, or a crinoid arm waving in a clouded sea? It sounds like home recoding itself. The familiar dries up. New rules arrive with the thunder. Somewhere south, in basins that will one day be Argentina and Brazil, small, lightly built archosaurs test the edges of floodplains. They are not yet rulers. They are fast opportunists in a world that keeps resetting the board. Geologists piece this together from repeating clues. Across Italy, the Alps, China, and Japan, the same signals stack up. Carbon in limestone swings lighter, a sign the air was flooded with volcanic carbon. Mudstones carry sudden enrichments of mercury, fallout from giant eruptions. Even the seabed flips, steep platforms giving way to low ramps as the builders of white limestone falter. Call it a mega-monsoon, a heat engine that dragged moisture deep into the continent. Where deserts had ruled, cloud streets marched for weeks. New soils formed, then slumped and washed away. Green won ground, stability lost it. Not every lineage suffered. Crocodile cousins and small archosaurs prowled floodplains. Insects boomed in the humid belts, and some were sealed in resin that hardened into amber. Tiny time capsules that still hold mites and a fly from that world. New forests meant more resin and more prey. But in the water, parts of the old guard faltered. The stage was being rebuilt, plank by plank. If you could watch a million years in minutes, rivers would writhe, shorelines jump, and ash lines blink on and off with each burst of fire. Take a breath. The pressure is still rising. This was not a single season pushed to the extreme. It was a set of climate jolts that stretched over more than a million years. Each time the carbon cycle lurched, the rocks recorded a sharp negative swing in carbon isotopes. Each time volcanoes stirred, the sediments picked up dustings of mercury, a subtle calling card of giant eruptions. In between, the world tried to steady itself. Floodplains knit together, then fractured. Lakes filled, then went foul. Coasts built reefs, then watched them drown. Wrangellia's fire primed the atmosphere. Warm seas pushed moisture inland, and Pangaea's size let that moisture fall far from the coast. The result was a mega-monsoon, heavy enough to rewrite landscapes planet-wide. For countless generations of animals and plants, climate was no longer a backdrop. It was the plot. The pressure builds. When the sky finally opened for good, winners and losers changed almost overnight. Water became architecture. It carved new channels in weeks that once took centuries. When the sky finally opened for good, storm tracks locked across Pangaea. The interior, once a mosaic of salty pans and wind-scoured dunes, turned into a chain of floodplains, lakes, and swamps. On the long beat, coasts marched inland, and the map shifted from brown to green and gray. On coasts facing the Tethys, rain meant trouble. Rivers that had carried a trickle now delivered whole landscapes ground fine. The clear, lime-producing seas dimmed. Reefs, already sparse after the end Permian, were outpaced by sediment and acid water. The great carbonate factories, once built by microbes that turned light and chemistry into limestone, faltered. In their place grew low-angle ramps of shell grit and ooids that rolled like tiny pearls across the seafloor. The very shape of the shelf changed. Warm water held less oxygen. Nutrients washed in by floods spiked blooms that decayed and pulled what oxygen remained from deeper pockets. Patches of the sea slipped into sluggish, breathless states. At times, whole basins went anoxic. This was not the global smothering of a mass extinction, but it was enough to trip food webs in many places. Some communities winked out. Others retreated to refuges. Storms came in trains. You can read them in stacked sandstone, each bed a surge, each surge capped by mud and plant debris. Fires flashed when lightning found dry crowns between deluges. Then the rain returned and pressed charcoal into the soil. The pace of change outran the pace of adaptation. Old kings stumbled. Rhynchosaurs, bulldog-jawed herbivores that had dominated many Triassic plains, began to fade from their generalist roles. Only a few hyper-specialized branches hung on. Dicynodonts, tough-beaked herbivores, shrank in range. In rivers and lakes, some fish and amphibians found new room in the warmth, while others failed. Offshore, conodonts and certain ammonoids fell in step with the oxygen crashes and the sediment pulses. Nature kept switching the settings. Animals that could not switch with it paid. Listen for the microbeats of suspense. A bank caves and buries a nest. A lake turns to soup in a month. A delta starves, then grows twice as wide in a single wet decade. Each small flip forces a choice. Move, shrink, reinvent, or go. Yet the same rain rewired the plant world into something recognizably modern. Conifers and Benedictalians spread fast, ferns flushed across openings after every flood, and peat swamps recorded the return of true coal. With forests came resin. Droplets fell and trapped tiny travelers. In northeastern Italy, amber from this interval preserves mites and a small fly, the oldest arthropods ever found in amber. Life was improvising at speed. How do we know the water and chemistry changed together? The cliffs say so. Around the old Tethys, 4 wet pulses rise like rungs on a ladder. Each shows a plunge in carbon isotopes, a dusting of mercury, and a switch from lime mud to storm-laid sand. Volcanism, then warming, then rain, then runoff, then oxygen loss. Reset, then again. The longer rains opened corridors across the supercontinent. Animals tracked new vegetation belts and fresh water. The same rains blurred old barriers and mixed faunas. New predators met new prey. Each meeting was a test. A few lineages found their signature. One of them will rewrite the next 150 million years. There is one more hard scene to play through. The cost of endless rain posted its bill in the oceans first. In shelf seas, clouds of silt dimmed light. Acidified waters gnawed at carbonate shells. Warmth bled oxygen from deeper pockets. Conodonts, the eel-like creatures whose tiny tooth elements pepper Triassic rocks, took repeated blows. Some ammonoid lineages, once clockwork survivors, crashed with the oxygen. Crinoids and bryozoans reeled where smothering mud stole clear water. It was not a single sudden kill. It was pressure, released in waves. On land, the headlines read differently but echoed the same rhythm. Rhynchosaurs held on in a few specialized forms and then dwindled. Dicynodonts withdrew to pockets. Crocline archosaurs did well in the sticky margins. Amphibians surfed the wet years. The story turns on versatility. If you could handle floods, mud, and new heat, you had a chance. If you needed the Triassic world as it had been, your time was short. There were bright threads. Forests thickened and diversified. Conifers rose to dominate uplands. Benedictalians and ginkgophytes joined the canopy, and ferns carpeted every fresh scarp. Peat swamps grew again after a long global gap. locking carbon into new coals. In that sticky shade, resin dripped and captured insects. The oldest amber with arthropods dates to this interval, a whisper of life preserved in honey glass. You can almost hear the rain on leaves above it, every pulse set up a micro cliffhanger. A drought window opens and a browser surges north. The next wet year erases the route. A lake basin that fed 100 nests for centuries flips to a soup that kills fish in days. A delta builds a platform for a new forest. A storm next season tears it to sand. The board keeps tilting, and every tilt clears a few spaces. Into those spaces step the small, the fast, the adaptable. In South America, on floodplains now called the Ixigualasto and Santa Maria formations, the new choreography is visible bone by bone. Slender, fleet bipedal predators, early theropods, pick paths along river margins. Stockier herbivores, the first true sauropodomorphs, probe new plant belts. Between them, small armored oddballs and croc cousins fill the cluttered middle. The cast still looks minor beside the hulking holdovers, but there is a shift in tempo. The quick are learning to lead. This is the pivot many paleontologists argue over. Did the rains make the dinosaurs? Or did they simply move the furniture and the new tenants took advantage? The timing lines up cleanly enough. The pulses of climate stress and biotic turnover in the Carnian dovetail with the first clear spikes in dinosaur diversity. Maybe the storms did not crown them, but they cleared the hall. Edge of frame, a question waits for us. If a million-year storm could scramble life this hard, what would a human-made storm do in the centuries we control? Would humanity survive if this happened again? Leave your take below and what early warning you would watch first. Back to the Triassic. The Carnian pulses fade, but the world they leave behind is not the same. The old plant guilds that love dry heat hold less territory. The new ones that drink water and grow fast spread. Insects knit new food webs through wetter canopies. Rivers carry fresh nutrients to shelf seas that will one day seed reef innovations. And the light-built archosaurs that ran the edges keep finding reasons to grow. The storm runs out of drama. The plot does not. One more reveal hides in the rock record. After the rain, some basins grow quieter again, but the echoes of the pulses remain embedded. You can see them in the carbon swings, in the grains that say flood and in the coal that says forest. Most of all, you can see them in the cast lists. The mid-Triassic was ruled by different names. The late Triassic will be ruled by new ones. Their reign begins now. The camera pulls back and we see a new balance. The sky is calmer, the ground still wet in its bones. In many places the rains ease, leaving behind broader floodplains and thicker forests. The world is still Triassic, but the deck has been cut. The animals that can move fast and breathe hard in warm air find the keys. The animals that need old rhythms keep slipping. This is the rise, not yet of giant thunder lizards, but of lineages that will become them. In the South American basins, we meet Herrerasaurus-like hunters, quick and lightly muscled. We meet early sauropodomorphs that still walk on two legs most of the time, but already wear long necks and big lungs. We meet armored little eccentrics and nimble omnivores that fill every corner of the food web. When you lay the dates on a chart, the surge in dinosaur diversity and abundance follows the wet pulses by a breath. The world made room and they stepped into it. The idea is not that rain invented the dinosaur. The idea is that rain, fired by volcanism, reset enough habitats at once to make 1,000 small advantages add up. Dinosaurs were originally minor players among many archosaurs. Then storms shuffled the board. Plant belts shifted, old herbivores thinned. New corridors opened. Predators that could run long, cool their bodies, and hunt in packs found repeatable success. Herbivores that could crop tough conifer needles and move between flooded zones found paths. From here, the story accelerates. As the Carnian gives way to the Norian, dinosaurs are no longer rare. They are common in tracks and bones across what will become South America, North America, and beyond. They do not yet dominate every niche, but the arc bends their way. The modern world in outline is visible too. Conifers and ferns rule vast tracts. Coal returns to the stratigraphy. The seas start to build new kinds of carbonate communities that will one day seed reefs. The Cretaceous is a long way off, but some seeds are planted here. Pull the camera even wider and you can make a stronger claim. Many researchers argue that the Carnian is the dawn of the modern world. Not because it looks like today, but because the rules start to rhyme with ours. Complex moisture-fed forests return and run large carbon budgets. Plankton systems respond to bursts of nutrients and warmth. Regional climates flip with distant drivers. Volcanism can tip the whole machine. This is where past and present touch. We are not living through a Wrangellia replay. We are pushing carbon faster than most natural events, and we are not building new floodplains to take the hit. But the physics that turned heat into rain and rain into biotic turnover in the Triassic still run today. Warm air holds more water. Warmer seas change storms. Runoff changes coasts. Coasts change oceans. Oceans change life. The network does not ask permission. One last curveball from the Carnian helps the analogy. The wet pulses did not just knock species down. They rearranged connections. Corridors opened. Biotas mixed. New rivals met. That kind of mixing reshuffled the arms race and helped new groups take off. In our century, climate and land use are opening and closing corridors every year, and the winners tend to be fast, flexible generalists. The lesson is not doom, it is motion. Climate change rarely acts alone, it acts by moving the playing field. The dinosaurs still have hurdles ahead. There will be setbacks before they tower. But the hinge has already turned. The rain did not crown them, yet it sent them the invitation they needed. The next 150 million years will write that invitation in big letters.